original position. So when the current flow through the solenoid B, the piston in the cylindrical moves downward and the case causes the barrier to get down. So limit switches are used to detect when the barrier is down and also when fully up. So PLC, so coin operated switch. It is having the input module and output module. So already we know that PLC having different kind of n number of input modules and n number of output modules. So input modules are coin operated switch, entrance barrier setup. So entrance barrier switch down, input when car at exit barrier up switch, exit barriers down switch. In output side, they have entrance A, entrance B, and exit A and exit B. That is for actuators. They connected in the output module. Then X40, so X400. That is coin operated switch at the entrance to the car park. So these are the pin connected with the particular application, particular input. Okay. 6 inputs X4002, X45 is required for the PLC to send the 6 limit switch position, namely coin operated switch, entrance barrier up switch, down switch, car at exit barrier switch, exit barrier up switch, exit barrier down switch as indicated in the diagram. Whenever a switch is operated, so 0-volt signal is provided to the corresponding input and otherwise plus 24-volt signal is provided to the inputs. So 4 inputs are required to operate the 2 solenoid valves A and B. Okay, these are the construction ladder diagram of the barrier system. These are the ladder diagram of the barrier system. Then we will see the operating steps of barrier system. So these are the steps. The car enters the car park. The driver insert the coin to the cash box. In barrier opens and let the car enter to the park. The in barrier closed subsequently. The driver parks the car and leaves the park for his work. So after driver's work is over, he returns to the car. He drive the car to the front of the out barrier. Okay, the out barrier open and lets the car to leave the park. The out barrier closed subsequently. The cycle then repeat for the next car. So this is the simple operation which is done in the electronic car barrier system. These are all controlled by the common logic. Okay, so this is simple logic. Okay, here we have trails and rungs we have. So that is X400 is a normally open condition. M100 is a normally closed condition. So Y430 will be the solenoid valve A for entrance barrier. Okay, so like that. So these all the conditions are done with the direct some logic. So first one is done with the XOR logic. So second one also direct logic. That is if X401 is enabled, that is if there is power supply means, so it will execute the T450, that is M100. Like that they will explain. These are the concept. So finally it will produce the end. This is the ladder diagram for car barrier system, parking barrier system. Okay, these all the conditions are controlled by the PLC because PLC provide the high power voltage, that is it can work in the 230 or 440 volt. This is the main advantage of PLC used in this condition, electronic car barrier system. Okay, so I hope that the both case studies are very useful for your future considerations. Okay, that means, and finally I can conclude with that the mechanical system is controlled by the electronic unit, that is mechatronics, which is cover more industry operations. Okay, so it is a very useful topic for your future studies. Okay, so okay, thank you.